Hello and welcome to our channel once again. Today's topic is how to create a linked list, and then we'll move on to how to display a linked list. So this is the most first thing that we have to know before moving on to more problems of single linked list. So in my previous video I showed the mechanism of linked list, that how it actually works and what are its types, and what is head and what will be the address bar of the last node, how does the nodes looks like. So I have covered those topics, and now we will implement those things on different problems regarding single linked list, and then you guys will understand it more thoroughly. So let's start it. So I told that linked list is a collection of nodes, right? The nodes will have two parts. One is the data part and the second one is an address part. So let me input a node into the computer. So this is a node. Like when I enter my first node, it will be stored like this. This is the first node. Let me say I have given 5, that is my first node, and the address part of this node will point towards null because it doesn't have any next node yet. I have given just a single node, right? Now again I want to enter another node. Let's see what happens. So this is the next node that I have given into the computer. This next node will be the very next of the first node. And I forgot to say that this node, this particular node, we will call it as head. This is the head node, and all the other nodes we will simply call it as nodes. So this is the second node that I've given inside the computer as input. Let me say it's 6. So I've given 6 after 5, so they will be connected like this. This is the address part of 6 and this is the address part of 5. So this address part of 5 will store the address of this node. Let me say the address of this node be 1002, and let me say the address part of this node is 1001. So this 5 address part will store the address of 1002. Alright, so in this way the process will go on. In this case the last node is 6 and hence it is pointing towards null. Again, if I want to enter another node, let's see what happens. So this is the third node that I have given as input inside the computer. Let me say it is 7, and what is happening? This address part of 7, let me say it's 1003. It's just assumption, there's nothing accurate. So this address part of 6 will store the address of 1003, and the address part of 7 will store the value of null. So the mechanism of single linked list creation is this. The first node we will call it as head, the second node and on all the other nodes we will call it as simply nodes. So and the address will be stored the next node. Each node will store the address of its very next node. So I think the things are clear till now, so let us implement this thing on coding. So let's start. So here I have written the initial things that are needed to conclude a program of linked list. That is, I have declared here type def struct node. Now this whole thing will define a node which has a data part and this struct node pointer ad. This ad part is the address part, like it will store the address of its next node, like I said from the previous slide. So next we have to first declare the head as null. Why we have to do that, I will tell you. Node star head equals null. So now this node, because I have written here node, that's because I have given it a nickname, that is small node. Otherwise I had to write struct node. So better to write node, simply smaller. So this will be like node star head is equals to null. Now what is this head actually here? This head is a pointer, like a variable that I want to point the first node. So here from this linked list, here we can say that this node is obviously the head node. I told you that in a linked list the first node is a head, so I am declaring a pointer which will point only to the first node of our linked list. Right? Things are clear right now? So let us start. Now here the pointer is pointing towards null, and the return type of this variable is node, because whenever in a linked list, whenever we are dealing with the first node of any linked list, we have to take the return type as a null, because in this case the head will be changed, right? Like if I want to enter any element from the left hand side of a linked list, like from the head side of the linked list, then we have to deal with the head, like we have to shift the head towards right. So we have to deal with the head, then also we have to take the return type as node, else things won't work, because we have to deal with the first node, so we have to take the return type as node. Done. So let me declare a prototype of function. So I have declared a prototype of this create function, and inside this function we will write the code to create a linked list. So what we have done here, we have taken a printf statement which is printing press 1 to create. Like this is a style that I follow actually while doing linked list. Well, you can do it like with any functions. You can do it in there are multiple ways doing a program, right? So I follow this style because I simply prefer this, because by this way I can uh, concatenate more functions, right? Like creating, display, switch, add at the beginning, delete at the beginning. So I can do all the things in a single code. So I follow this rule, I follow this function, and it's simply cool. So what I have done here, actually I have taken a printf statement that press 1 to create. Like if I press 1, then the program will run, and then the create function will run. And to do that I have taken a switch case statement, and I have to declare this thing. Let me say int ch, obviously because it's an integer type. So let's write the case statement. So this is the first case, because today I'm gonna only discuss with about creating a linked list, so I will not go into adding any other function. So this is the case 1, that if I press 1, then this thing will run. Now what is this thing actually meaning? I have defined that this create thing, this create function is will return a node type variable. Now what is a node type variable? Now when I'm creating something, the head value, like at first the linked list is null, right? There is no nodes, and then I enter the first node. So the linked list will store some value. The head will have some value. At first the head was null because I was pointing it as at null. Then I pointed it to a node that I have given as input. So the head, so I have to return the value of the head, else I won't be able to use it in any other functions that I will give in future. So I have to return the value as head, because the node that I have entered, the first, it will be stored inside this head value. After this, the head won't be null anymore. At first it was null, but then I stored the value of create. Alright, let me take another while loop for again infinite while. I've taken a while loop here because if I take it like this, then this thing will go on again and again, so that after I do this function of create, it will again prompt like printf1 to create a linked list, like if I want to create another linked list like that. So I've just given you, you can do it in any ways. This is my style of doing, so it's okay. Up to this the function is basically over. So now we have to declare what this create function will do actually. So let's write the create function. Now this node star create that I have done, because we are dealing with actually pointers. This head is a pointer, and then temp will come as a pointer, as a temporary variable. So and the value that we will return is also a pointer, because we are returning the head value, right? So we have to take it as a pointer. Alright, node star create. Whenever we are dealing with the head thing, we have to take it as node star and the function name. So up to this I think the things were clear, so let us move on to it. So now what we have done here, actually this thing I have declared two pointers of node of type node, like for the user defined data type. So what I have declared here, a temp and a p, right? Now again I have declared this temp as in a dynamic memory allocation, so that the memory becomes expandable, and here we have declared that int enter data. Now we have to enter the data, right? Because from the slide I showed you that I have given 5 as input, so I have given a data as input, right? So I have to take the data in integer type. So I have declared int data as integer type variable. So let us scan it. So I have scanned the data. So now to put this data inside this node, we have to do that structure function, and assuming that you guys know how structures work, because this thing is very high level, and so you have to know structures and the concept of pointers and all, and dynamic memory allocation. So assuming that you guys know what structures are, or else I will cover all those topics, dynamic memory allocation, if else loops and structures and all. But alright, these are for some of my views. So alright, that is temp temp has two parts because temp is a node type variable. So this node type variable has two parts, right? One is this address part and data part. So where I want to store this data part, I want to store this data part into this data part of temp, because temp is a temporary variable that I am declaring it as a node. So inside this temp data I want to store this data that I have declared here, or I can simply declare it as D so that it will be better in understanding. So let us, inside this temp data I will store it as T. So what is happening here, I'm just showing it by drawing. So I have written here as temp.data equals to D, that is the data that I have entered, and temp.ad, like the address part of temp, is pointing towards null. So what I have done actually, I have created a node that is temp, and inside this temp I am storing this data D, and the address part of this node is pointing towards null, like this. It is pointing towards null. This is the first node that I have created. That is an independent node. Actually, this is an independent temporary node that I have created. Now what? I have created the data part as D. Any value that I will enter as D, it will be stored inside this data part of temp, and the null value will be, and the address part of the temp will be a null value. So what will be next? Next I have to check something. Now what is happening? I have declared an independent node temp data as D and temp add as null. So I have declared that, I have said that check if head equals to null, head equals to temp, right? So what does it actually mean? Here this is the first node, the first independent node that I have created. It has a data part that is storing the address of D, storing the value of D, and the address part which is storing null. Now if I have to check that is head is null. Now here universally I have declared that head is null, because at first there is no linked list, right? Then how can head store a value? Head is obviously null. So head is null, that is satisfied because there is no other linked list. I'm just creating a new linked list, so the head has to be null. So head is null, so head will point towards temp. What is happening? I am taking the pointer head and asking it to point towards this independent node that I have created. So this independent first node that I have created is, the head is pointing towards it. This temp is the independent node and head is pointing towards temp. So temp has become the head. Now if head is not equals to null, now when I want to enter the second node, the computer is checking now obviously that if head is null, it is checking that is head null. No, it is storing a value, right? Head is now storing a value. It is storing the value that I have given as a first node. So head is not null. So what are you going to do now? I have taken another pointer that is P, and I have asked that pointer that you also point towards the head. So what is happening? Head is already pointing towards head, towards this temp that I have created right now. So I am asking another pointer, let's say it is pointing, and that pointer I have named it as P. So I am asking another pointer P that you have to point towards head. The place where head is pointing, you have to point towards that place only. Alright, so P is pointing to the same node where head is pointing at first. So done. What I have done here, I have taken a while loop, that is p dot add not equals to null. Now what is this? P dot add means p is pointing towards this temp node, right? Let me remove this temp thing because the work of temp is done. P is pointing towards this head node, right? Now from the code we can see that this whole thing will be in a loop. So what I have done here, actually I have taken another variable, that is s, and I have asked that it will be inside, it won't be inside a loop. So firstly it will ask me that when I enter any data, press 0 for no and 1 for yes, and I have scanned it as this new variable, that is s. While s is equals to run 1, then this code will run, else not. So when s is equals to null is 1. So at first I am creating the first node that I have told just now. Enter the data, temp data is equals to d, and temp dot add will be null, and if head is equals to null, this head will point towards temp, and obviously when I am creating the first node, head is obviously null, so head will point towards the temp when I have given the first node. Now for the second node, this loop will run again. Like for example, I have to take another statement here. So what I did here, I have taken another statement, that is when I enter more data, like if I want to enter the second node or the third node, if I want to enter more nodes, then press 0 for no or 1 for yes, and I have taken the same variable that I have taken initially, here. So this will scan the same variable, that is s, and it will again check by this while loop if s equals to 1. Now if I enter again s equals to 1, then the loop will again run, and then I can enter the further nodes. That's how the code will work. So now after I created this first node and I have initialized head as temp, and I want to now enter another node. So after entering the first node, this loop will break. Not the loop won't break. Actually, it will come to this print enter more data, because it will come out of this if else statement. So if I press 1, then I can enter the second node, right? I have taken 1, s equals to 1 now. It is again satisfying this while loop, and it is again going inside this loop. Again a variable, dynamic, by this dynamic variable allocation. So I have again allocated a memory for temp. I have entered again a data. I have again scanned that data, and I have again initialized that data with d and equals to null. So what is happening? Actually, I have already created this first node, right? Now what I am doing, I am creating another independent node like I created at first. So what I have done, while inserting the second node, at first I have created this independent node once again, like I did when I was dealing with the first node. So while I am dealing with the second node, I have again created an independent node, and I have entered a data, let's say d1, which will be again inputted by this variable d only. So just to make you understand, I have initiated this as d1, and again that node will point, the address part of that node will point towards null, and as temp is a pointer, this temp will be pointing towards that independent node only. So this statement is doing this work. Up to this statement I have created, I already have this node which I am pointing as head. I have p point, not yet, the p is not yet pointed towards head, so I can rub it out or let it be there, because in the next node I have to point it there. So while head is pointing towards a node, I have created another independent node. So now this thing is checking that whether head is null or not. When I was creating the first node, head was null, so I have no restrictions to follow this code. But now head is not null, head is pointing to a node, right? So head is obviously not null. So else what will happen? I have taken another pointer and I've asked it to point to the node where the head is pointing. So head is pointing to this node, so p will also point to this node, right? P is pointing here, and I have taken a while loop. I have taken that now p is pointing towards this node, right? And p has this address part, the address part of p and the address part of head are same now. So p's address part is this square, this whole thing. This is the address part of p, and this is also the address part of a also. So while p add not equals to null, p is equals to p dot add. Now what is happening here? P add is equals to null, right? Because it's the first node and the address part will be null because there is no other nodes left. So the address part is pointing towards null. So if it happens p is equals to p dot add, the loop will not execute, right? Because the address part is pointing towards null, it is not satisfying this condition. So in this case what will happen? It will happen like this. So what is this thing actually doing? This thing that whenever p dot add equals to null, like this case, p dot add equals to null, right? Whenever this case happens, p dot add will cancel this null thing, but will start pointing towards the temp, like the variable like the independent node that I have created just now. This address part of p will point towards the address part of that independent variable. That's why I have created temp, that independent variable that I have just created. Now what about the third node? Now if I want to enter the third node of this, so what will happen? Let's just see. Let's assume that I have given 5 as input as the first node. So what is happening? I have told that how the mechanism is actually working. So let's say 5 is the first node and 6 is the second node that I have given as input. So up to this I think the things are clear. Whenever the second node, I am forming the second node, the temp was pointing towards that independent node. Now the first node address part was pointing towards the null, so I have given this while statement that while p dot add not equals to null, but p dot add was pointing towards null, right? Because the first node was pointing towards null and the p was pointing towards the first node. So what is happening? P dot add is pointing towards that temporary variable that I had just created. in the last time that temporary variable was pointing towards the second node. So the p dot add will be pointed towards the second node, and this had become the second node of the linked list. And obviously temp was previously actually pointing towards null, so things won't change. That node will be pointing towards null only. So up to this things are right. Now I want to enter another node, the third node, let's say 7. So what is happening? It is asking me that want to enter more data, yes or no. As I have inputted 1, s equals to 1. So again the loop will run while s equals to 1. I am again creating a dynamic memory allocation. I am again creating a node, memory allocation for temporary variable. I am again asking for a data, enter data. I am inputting the data as 7. So scanf %d. Now temp.data will store this 7. This temp.data part is storing this 7, and temp.address, this address part will point towards null that I have written here. Now it is again checking if head is equals to null. Is head null now? No, it is pointing towards the first node, right, like it was doing before. Head is pointing towards the first node, so things won't work now. So this statement will not be followed. Else, now head is not equals to null. Now what is else? Else I have again asked the p to point towards the head, like towards the node where head is pointing. So head is pointing to the first node, so p will also point towards the first node. Now it is checking while p dot add not equals to null. So here p dot add, is it null? Obviously no, because p is pointing towards the first node and the address part of the first node is pointing towards the address part towards the address of this second node, which is 6. So obviously p dot address part is not null, right? P dot address is now storing the address value of 6. So what is happening? P is equals to p dot add. If this condition is followed, this condition is satisfied now. So p is equals to p dot add. So what is happening? I am moving this p to this. I am moving this p to here. That's what this statement actually means. P is equals to p dot add. P dot add, like now p is pointing to the next node. P dot add. P dot add. What is p dot add actually? P dot add actually signifies this node. This node actually we can call it as p dot add. P dot add is the second. P dot add actually means the next node of p, the next consecutive node what is after that p. Similarly, if I had taken the temp is equals to temp dot add, things would be similar. So temp dot add means the immediately after node, like temp is a node and the immediate after node of temp we can denote it as temp dot add actually. So we have to clear this p out. P is not pointing towards the head right now, so p is pointing towards the next node. Initially p was pointing at here, so now p is pointing to p dot add, like the next node of p. So now p is pointing to the second node. Now it will again check while p dot add is equals to null. Is p null? Yes, p dot add is equals to null now, because this is the second node and the second node is pointing towards, there is no third node. So p dot add is now pointing towards null. So what is happening? P dot add equals to temp. So now what is happening? The next node of p that we call as p dot add, like this is the connection line actually, is now pointing towards temp. So what is happening? This p dot add is now pointing towards 7. So now the third node is created. P dot add is equals to temporary variable, like that independent node that I had created at the beginning. So now the P dot add is pointing towards this 7, and 7 is obviously initially was pointing towards null, so no change will be there. So now the linked list is created, right? A 3 node linked list is created. Similarly, in this way you can enter the fourth node. If I want to enter the fourth node, what will happen? I again have to create a temporary node with 2 paths. Obviously, let it be we can say as 8, and obviously the address part of temporary node here will be initially null. Let's take it as initially null. It is null, it is pointing towards null, and now the temp will start pointing towards this node. Temp is now it will now point towards this node, not anymore here, because temp is only used to create an independent node which I can later insert into the linked list. Temp is now pointing towards here, and temp.next equals to null. Again, is head pointing towards null now? Head is not changing, right? Head is pointing towards head only, towards the first node only. Head is not changing, so head is obviously not null. Else p equals to head. So now again I have taken p is equals to head. So again now p will stop pointing towards this 6th thing, and now it will again start pointing towards the where head is pointing. Head is pointing towards the first node, so p will again point towards the first node. This statement means that. Now while p dot add is not equals to null, is p dot add null? Obviously no. It has a node, it has an address part, it is storing the address of this this node. Obviously it is storing the address of this 6 again. So p dot add not equals to null, condition satisfied, p is equals to p dot add. So p is equals to p dot add means p will move towards the next node. So now p will be pointing here again, and this is p. Again it will check while p dot add not equals to null, is p dot add null now? No, I have created the third node, right? Now p dot address part will point towards the towards this 7, right? So p dot add is obviously not null because address part is storing the address of 7. So what is the statement? P is equals to p dot add means I have to move the p towards 7. So again I have to move the p. The p is again moved. It again shifts to 7. So now p is pointing towards 7, and 7 is pointing towards null, as we can see. So now this condition is not valid now because p dot add now is null. So what is doing? P dot add is pointing towards temp. So now p dot add was pointing towards null. Now it will change it, and it will start pointing towards 8. It will start pointing towards 8, and 8 is initially pointing towards null, so things are done. A linked list is created. So that's how we create a linked list. So now before ending the video, I have to give 2 statements so that the program will run correctly and in a good manner. So now the last statement that we need to give is, obviously because we haven't returned any value, right? We have to return the value of head in order to store the head value inside this statement. inside this. We have to store the value of head inside this, so I have to return the head value, right? So we have to simply write return head, and after that, when a linked list is created, I need the code to prompt that the linked list is created simply. So I have to just write a printf statement inside the switch case, and it will be like linked list is created. That's it. So I hope you guys have understood that how things are done, how creating linked list is done. So well, let me end the video right here because the video has become too long. So in the next video I will tell you how to display the linked list, and later onwards we can solve many more problems. And also let me end the video up to here, and I hope things are clear now, and if not clear then you can comment. I will be very happy to help you. So okay, thanks for watching, and please like, share and subscribe our channel. So have a good day.